Hey everyone, I just want to make a video here going over lesson 2 in unit 6, our last unit on annuities. I know I went over this very quickly with cohort A, and cohort B will be going over this in detail tomorrow, but I figured I should probably do a video lesson for at least this one because I know that there's a lot of new concepts here that can be a little bit difficult to understand. So hopefully by going through the lesson and hearing it and seeing it in a different way, maybe it'll help click a little bit more. I also want to go over a couple of little calculator techniques that we need to know how to use. And again, hopefully, I'm hoping you covered compound interest yourself. This lesson is going to be more focused on annuities. And if you don't mind, I am going to focus more on the examples. So I might skip a lot of the actual reading and any of the prefix that we have there. I'm going to focus more on the examples. Okay, so first thing, what is an annuity? So we talked about this in class already, but an annuity is a series of equal regular deposits or payments that are made at equal time intervals. So what that means is if you decide that you are going to make payments monthly, then that means that you're going to be paying you're going to be making monthly payments every single month, right? So you don't miss a single one, and they have to be equal in terms of their deposits. There are examples of when you have deposits that are not all the same, but for all these examples, we're assuming that we have equal regular payments. Okay, so we're not skipping, and we always go by the same interval each time. And the time interval, it doesn't have to be monthly or yearly. It could be bi-monthly. So it could be once, depending on how you interpret it, once every 2 months sometimes, or sometimes it can be interpreted as twice a month. It could also be weekly, which means it's every single week. Daily, which means you deposit every single day or you get paid every single day. So in this case, we're going to focus on annuities. So essentially, that means that we have regular payments throughout. So if this is the time that we start at, and let's say that you decide to take out the deposits after 5 years. If we decide to do monthly payments, then we might have something that looks like this. So in this month, we're going to make some payment R for regular payment. Then the next month, we're going to make another deposit of R payments, and then another one of R all the way up to 5 years. And this is basically what an annuity is, that we make regular payments throughout. In all these examples, we're always going to assume that the interest rate is compounded at the same with the same frequency as you make payments. So what that means is if you decide to make monthly payments, we're always going to assume that the interest is compounded monthly. Always assume that. Okay. So it is possible to look at examples where the payments are, for example, monthly, but the interest is compounded weekly. But we won't look at examples like that. We're just going to focus on when the monthly payments and the frequency of the monthly payments and the frequency of the payments and the frequency of the compound interest is the same. So how do you actually find out what the total of an annuity is? So there isn't actually a way to calculate all this. And this is just a small example, just showing you if we had 5 payments of $1,000 for 5 years, and they were made at the end of the 5 years. So what you could do is you could figure out how much each of the payments will grow into over the 5 years. And obviously the payment that's made in 1 year has, at the end of 1 year, only has 4 years to grow. The one at 2 years only has 3 years to grow, and then so on, right? And then what you could do is you could calculate the total amount for each of them, and then that would tell you the total of your annuity. Now, this is a very time-consuming way to do it, and there definitely is a shortcut to this. And I don't want to go too much into too much detail of how we came up with the formula. I want to just focus on using the formula. That's the most important thing for us. We're getting into practicality of it. So the formula to help us find the future value of an annuity is to simply take the regular payment that you are either receiving or you're making, and we're going to multiply it by this fraction over here. And I'll explain step by step what this means. 1 plus I refers to basically you're adding on whatever the interest rate is, right? So if I am paying 5% interest, keep in mind that I would be multiplying by 1.05 every single time that I'm compounding the amount, right? So I am going to write 1.05 and I'm going to raise it to the power of the number of payments that I'm going to be making. And I subtract 1 and then I divide by the interest rate. Again, you don't need to know what this is. You just need to know how to use it. And we will talk a little bit more about this. Just want to make sure you understand some keywords here. Future value FV is going to be what the total amount of all the deposits made throughout the equal intervals. The PMT, sometimes known as R, is the regular deposit or the payment that you make. N is the number of payments that you make. So for example, if it was yearly and it was for 5 years, then that's pretty easy. It's going to be 5 payments. But if you decide I'm going to make monthly payments, let's say I decide monthly payments, for monthly payments, since it's 5 years, we're going to take the 5 years and we multiply by 12 because there's 12 months in a year. So that means you're actually making 60 payments. So I just want to make sure you understand what that means there. And of course, the I there is the interest rate per compounding period. It's really, really important. We talked about this in the first lesson, that you have to divide the interest rate by the number of payments that by the number of compounding periods that we have in 1 year. So for example, if it's compounded weekly, because we have 52 compounding periods, we have to take the interest rate and divide by 52. If it's compounded monthly, we have to take the interest rate and divide by 12 because there's 12 months in a year. So hopefully that kind of makes sense. And again, if that's a little bit confusing, go back to the first lesson. Just make sure you go over that as well. A little suggestion here for when you're doing the calculations, always calculate the fraction first. It makes it a lot easier in terms of doing all the calculations there. So I would focus on calculating what's in the fractions for, what's in the brackets first, and then multiplying by the payment. So how do we determine the interest that's paid? So once we know what the regular payments are, we're going to be taking the number of payments that we make, the number of payments that we make, which is N, and we're multiplying by the actual payments. And what we will do is we will simply subtract that off from the future value. So if in our other example, once we found out what the regular payments were, we're going to take that and multiply by how many payments we've made. And we're simply going to subtract that off from the future accumulated value of all the payments, right? And that's what an annuity is essentially you're making more than one payment, so it's an annuity. So if it is only one deposit, then it's just like what we did in lesson 1, where you simply use the compound interest formula if it's only one payment. But in this case, we're making multiple payments. And again, I'm going to skip that part. This is a little bit more advanced, but essentially whenever we're looking at this ratio over here, this fraction here, we should note that that's actually going to be greater than the number of payments. And the reason for that is because the future value should be larger than the present value. And that kind of makes sense, right? If you are putting money into an account, you better hope that the future value will be more than what you actually put into the account. If not, then you're losing money, which isn't very helpful. So let's look at this first example. So we are told that Jen deposits $500 at the end of 5 years for 5 years at 6% compounded annually. Determine the amount in the account after 5 years. So this one's still pretty easy because it's annual. So we first noticed that the interest rate is 6%. The regular deposit is $500, so that's our PMT. And we know that we are doing this for a total of 5 years. So our N is equal to 5. This one's actually quite easy because there's not really much they have to change there. So we have the PMT equal to 500. Interest rate is 0.06, and our N is 5. So what we're going to do is we're simply going to sub this into our formula. So instead of PMT, we're going to write 500. Instead of the I, we're going to write 0.06. And instead of the N at the top here, we're going to write 5. And when we sub that in, we end up getting 500 times 1.06 when you add these two together to the power of 5 minus 1 divided by 0.06. And technically, this should all be together, just letting you know, but it doesn't really make a difference at all. At the end, if you're able to do the calculations, you're fine. But just my own little advice here, I always like to do this fraction calculation first. Okay, so when I sub this in the calculator, and I'm actually just going to show you what this looks like. Sorry, 1 second, just getting the calculator going here. So if you can see the calculator here, I'm just going to show you step by step how we do this calculation. So we are going to focus on doing the calculation of the fraction first. So we have 1.06, and we are going to raise it to the power of 5 by using this little button right here. And then we take away 1, minus 1, and then we're going to divide by 0.06. So when I do this, I end up getting 5.637. I'm going to take that number and then multiply by 500. And that gives me a total answer of $2,818.55. So one really important thing when we're looking at money, we always round to the nearest penny. So in this case, when we're just review a little bit of rounding here, because we are looking at this rounding to 2 decimal places, we go to the second decimal place, we look at the number right after it. Because it is larger, it is 5 or larger than 5, in this case larger than 5, then we know we have to round up to 55. So it's going to be $2,818.55. So that's how we do the first example there. So let's look at another one here. So now in this case, we're going to notice that we don't have annual, it's not compounded annually, it's actually compounded monthly. So we have one little extra step here. So in this question, we're told that it is compounded after each month for 8% month, compounded monthly. So our regular payment is still 1,400. And we know that we're putting this into the account for 2.5 years. So let's do a little bit of math here. So the first thing, our interest rate. We know our interest rate is 0.08. So we divide this by 12 because, of course, there are 12 equal payments, and so we're spreading them out. So it's going to be 0.08 divided by 12. Our payment itself is only 1,400, and so we're going to write that as the PMT, right? That's our regular monthly payment. And then, of course, we still need to figure out the end. How many payments are you going to make? Remember, this is monthly, but we're doing this for 2.5 years. So we're going to take 12 and multiply by 2.5 years. So 12 times 2.5, or 2.5, gives us 30. So that means we're going to be making 30 payments. That's why the n is equal to 30. So we sub this into our formula. So we have 1 plus 0.08 divided by 12. Now you can figure out what 1.08 divided by 12 is, or you can just kind of wait your turn and just put it into the formula there. And we're going to do it all in one big step there. And then we are going to raise that to the power of 30 minus 1, and then divide by 0.08 divided by 12. This is where it gets a little bit tricky. So I'll explain how to do this one here. So on your calculator, there's actually 2 different ways you can do this. So we can either use our memory button. There is a memory button that we can use here, or we can simply write down all the numbers so that we can remember it, or we can do it in a slightly different order. So I'm going to show you the first way that I think is a little bit easier. So we take 1.08, we divide by 12. So I'm just simply taking the interest rate here, divide by 12. So do what's in the brackets first, and then I'm going to add 1, and then I'm going to raise it to the power of 30. Then I subtract 1. And once I have done this, I end up getting 0.220592, whatever. Now, this number that I have here is going to be divided by 0.08 divided by 12. So what I'm going to do is, I still haven't actually finished the whole question. So I'm actually going to save this answer into my memory. I store it to my memory by pressing M+. So, or if you don't have that button, you might have to write down, I would say to be safe, I would write down even like 6 of the digits, right? I would round it to like maybe 6 or 7 digits. Don't round to 0.2. It's going to be completely off if you do that. Make sure you have enough digits on here, okay? Not every single one, but I would at least have at least 6 or 7 digits there. So what I'm going to do is I'm now going to erase it. I'm going to start from the beginning, and I'm going to take that previous answer, and I'm going to divide it by 0.08 divided by 12. So I first have to figure out what 0.08 divided by 12 is. So that's 0.00666 and so on. So what I'm going to do is I can either try to store this or write down a couple of numbers. I'm going to go back and I'm going to write down what my memory was, which is right here. Perfect. And I'm going to be dividing this by, and again, it might look a little different depending on the calculator you're actually using there. Now I'm hoping this is working. Hold on, there's nothing saved here. Oops. Okay, I'm gonna have to restart it maybe. For some reason, it doesn't seem to work. Oh, these things happen. So what I'm gonna do is I'm actually gonna start off by doing the denominator first. So 0.08 divided by 12. I'm gonna store this in my memory or just write it down so you kind of remember it. And then I'm gonna have, and I'm gonna do the calculation and the numerator again. So we have 0.08, we divide by 12, we add 1, and then we raise it to the power of 30, minus 1, and now I take that answer and I divide by what the memory of the previous answer was, which is 0.08 divided by 12. So I'm going to divide by the memory, which is that one right there. And that ends up giving me 33.088. And I then finally multiply by 1400. And oops, I meant to write, I made a mistake. Sorry, guys. Okay, I obviously made a mistake. I meant to write 1400. I wrote 400. These things happen. I apologize, guys. So you're seeing me live here. And then when you are done, you should have an answer of $46,324.40. So that's how much interest, that's how much the future value of the payments, the future value of the annuity will be. Now, the next part, it says, how much interest did Mike earn? So this isn't all the interest that this person earned. What we basically have is a bunch of different deposits here. I'm just going to draw a picture. It kind of looks like this, from 0 to 2.5 years. And what happened is Mike made a bunch of different deposits throughout the years, or throughout the 2.5 years, and they accumulated to become $46,324.40. But keep in mind that that is not the total. That's not the total interest that was earned. Interest earned is essentially what's the difference between what you put in and what you ended up getting in the end. So the difference between them is simply going to be the total number of payments that I made multiplied by the actual payment, and we subtract that from the future value. So in this case, what we're going to do is we're simply going to take 1,400 and we multiply by 30 because we made 30 of those payments, which is 42,000, and we're going to subtract that from $46,324.40, and that gives us $4,324.40. So how do we find the regular deposit? So what if we're working backwards here? So if we are working backwards to find the regular payment, and all the other examples we were working to find the future value, now we're looking at finding the regular payment. Well, we just have to work a little bit backwards here. So what we're going to do is we are going to simply work backwards to figure out what PMT is. So we sub in what we know so far. So in this question, we're told that it is compounded semi-annually. So that means that we know our future value is, and I made a typo here. I totally meant to write 16,000. I wrote 1,800. I apologize for that. Our future value is 16,000. Our interest per compounding period is 0.075 divided by 2, which is 0.0375. And I know that the total number of payments that I'm going to make is 12 because I have 6 years and I make 2 payments per year. So if I have 6 years and I make 2 payments per year, do the math there, it ends up being a total of 12. So that's why I end up having 12 payments altogether. So what I'm going to do is I'm simply going to sub it into my formula just like before. I know my A value is 16,000, not 1,800. I apologize for that. I'll make that change. Is 16,000, and then I'm simply going to sub in 0.0375 into the formula to replace for I. And I go through the steps here, and once again, I'll show you in a calculator how to do this. So going step by step, we have 0.0375 to the power of 12 minus 1 divided by, and I made a typo there. Let me start again. 0.0375 to the power of 12 minus 1 divided by 0.0375, and I end up, and of course this gives me 14.8121 and so on. What I'm going to do here, this is where it gets a little bit different, is I am now going to take that number that I have here, which is 14.8121, and I'm going to store it in my memory so I can remember what that number was, or I can write it down. And again, if you're writing it down, don't round to just 2 decimal places. I would round to at least 6 decimal places if you can. So I'm going to store it in my memory, and I added it on there. Now I'm going to just delete this, and I'm going to take 16,000, and I'm going to be dividing by what the actual number was. And if I want to just recall the memory, instead of me writing it all down, I can just go to where it says MR, recall memory, and I believe that was the number. No, that was not the number, and I'm not sure what's going on here, but for some reason it's not remembering my numbers. And again, that's why it's always a good idea to write it down yourself. Let me just try it again. For some reason, it's not remembering the numbers correctly, because that's definitely not the correct number. I apologize, guys. I got a new computer, so it's been a little tricky getting used to everything here. So I'm going to be storing this in my memory. So store it, add memory, and I will erase this now. And I have 16,000 divided by my memory recall, which is also not the correct answer. I think that after each step, it's probably storing a couple different memories on here. I'm actually going to press memory clear, so it kind of forgets everything. If you ever want to start from scratch, memory clear. Let me let's try that one more time. I apologize for this, guys. I did not mean to make this many errors live, but this happens. And if you spot an error, let me know. 7.5. And now I'm going to store that in my memory. So memory, add memory. And then I go to 16,000. And I simply divide by 16,000. And I simply divide by the memory here. I definitely prefer to use my own calculator, but I have to use this one here. So I recall the memory, which is that one right there. Perfect, I got it. It took a while there. So it ends up being $1,080.20 if you round it to 2 decimal places. So that's how much I would end up with. Sorry, that's how much the regular payment should be, $1,080.20. And that's what should accumulate to give me $16,000 at the end of 6 years. Okay, present value. So just briefly going over this, present value is simply working backwards. In these questions, we're interested in having a certain amount of money in the future, and we're trying to figure out how much money do I have to put today so I can generate these future amounts. So this is actually a good example here. If I want $1,000 every year for the next 5 years, I need to figure out how much money do I need to put today so I can actually generate that amount. And obviously, just thinking about this logically, you don't want the amount that you're going to put in today to be more than 5,000, right? You definitely want it to be less than 5,000 because you are definitely going to be taking out you're going to be taking out $5,000 here altogether. So you want to make sure that what you're actually depositing today is less than that. You don't want it to be greater than that, right? If it's greater, then you really didn't get much of a deal, right? That means you deposited more than 5,000, but you're actually getting less. You're getting only 5,000 back. You obviously want the amount that you deposit today to be less, right? So intuitively, I think we kind of understand why the present value should be less, right? So what we're doing in this case, and again, I don't want to go into too much detail. There is a nice little formula we can use for this. And I say nice very, very loosely because it's actually not that nice. What we essentially do, luckily, it's actually really similar to future value. What we essentially do is we focus on solving the fractional part first, just like we did before, what's inside the brackets, and then we multiply by the regular payment. So in this one, it's actually, the good thing is the format has a lot of the similar ideas. We still have PMT, our regular payment, right? So that's our regular payment, how much we deposit each period. we still have our periodic interest. Basically, what that means is the interest for our particular period. And so again, a little example here, if it's monthly, we're going to take the interest rate for the whole year divided by 12. If it's quarterly, we're going to take the interest rate for the whole year divided by 4, and so on. I think you kind of understand the idea there. And then of course our n there is the number of payments that you're going to be making, right? So the number of regular payments, or the number of times that you have a compounding period, because they should match up there. So that's all we're essentially going to do. The one big difference, obviously, you're going to notice there's a switch in order. Before it was 1 plus I to the power of n minus 1. Now it's actually the other way around. It's 1 minus 1 plus I to the power of negative n. So the other second big thing you're going to notice is that the n is actually going to be negative. So the exponent there is going to be negative. So you really have to watch out for that. I'll show you on a calculator how to actually carry this out. So don't want to go into too much detail, but once again, how do you calculate the interest that's earned? So how much money you actually earn on your deposit? You simply take the total number of payments that you make, which is n, and you multiply by the actual amount of the payment, and you are going to subtract that from the present value. And again, this should be positive, and again, we know why, because this makes sense that the present value is going to be less than that, because you obviously want to deposit less money today so you can earn more in the future. So all we're going to be doing here to calculate the interest earned is take the number of payments made times the actual value of the payments, and you subtract off the present value. So in the first example here, if we have someone setting up an account and we're told in this case that they want an RSP, so that's what you're saving for retirement. They want to make sure that they have enough money so that they can withdraw $1,500 at the end of each month for a total of 20 years. So roughly speaking, this is kind of what the timeline looks like, right? So we have 0 years all the way up to 20 years, and we want to make sure that this person has 1,500 that they can take out at the end of every month for 20 years. And they're doing this for this whole length of time. So a couple things. We need to first figure out what is the regular payment. While the regular payment is actually given to us, we are told that this person wants a regular payment of 1,500. So our PMT is 1,500. We know the interest rate is 3%, but we divide by 12 because it's compounded monthly. So because it's compounded monthly, we divide by 12 there, and that gives us 0.0025. And our next part, we are also told that we have 20 years to invest, and they deposit, they make 12 deposits a year because it's monthly. So we simply take 20 times 12. 20 times 12 gives us 240. So what I'm going to do now is I'm simply going to sub this into my formula. So we have 1 plus 1.0025 to the power of negative 240, all divided by 1.0025, and then that gets multiplied by 1,500. Again, I would do this calculation first. So I'll just show you on a calculator how we do this. So just going through the steps here. Just hoping you can see that. What we will do now is we will simply do the calculation that's in the fraction there. So we have 1.0025, 1.0025 to the power of negative 240. So I type in 240, but I write it as a negative there, like that. And because I am subtracting this from 1, there's actually 2 ways you can do this. You can either try to memorize this number, just remember it there, but I actually find it easier. If you are actually subtracting a number, you're essentially just adding a negative number, right? So adding a positive number, subtracting a positive number is the same as adding a negative number. So what I'm going to do is, instead of taking 1 minus this whole number and having to memorize it, I'm just going to put a negative in front. It automatically makes that number negative, and then I simply add 1 to it. And so that ends up giving me 0.450777 and so on. Of course, you could write all these numbers down, but that takes a little bit longer. And then we divide by 0.0025, and that gives me 180, 180.31. And again, this kind of makes sense that it's less than 240 because we talked about this. You don't want to have the same amount or even something, or definitely not something larger for the present value, right? So it makes sense that we're just looking at this, the present value, we know it's going to be smaller than what the total amount of the payments are. So now we're going to take 1,500, we subtract off, we multiply by 180.31, and then we multiply together, we end up getting $270,466.37, and that's our present value. So that means that she has earned in the total investment the total amount that she has to deposit today, so she can withdraw 1,500 at the end of each month, would be $270,466.37. Sorry, I know it's a lot of details here, but hopefully that kind of makes sense so far. I'm going to skip these next couple examples. I really hope that you do go over them. They are a little bit more complicated, but the reason for that is just because I want to make sure that we're kind of understanding how to do the calculations first. So I'm hoping you can go through these examples on your own. I know it's a lot of information. I apologize. So I just wanted to get straight to kind of the harder part here. I would say sometimes it's the hardest part. How do you know if it's future value or present value? So future value, obviously, aside from the obvious that future value will normally be under the future value section of your textbook, it's not always clear which one is present future value or present value. So what you really are doing when you're deciding between the two of them, you're trying to figure out whether the payments are moving forward in time or backwards in time. So if we are thinking about paying, let's say that we're thinking about buying a house, right? And we're saving up money for the house. In this case, you're talking about regular payments that are being made so that your goal is to get a certain big chunk of money at the very end of it, right? So this would be future value because all the payments are looking towards the future, right? Everything is, all the cash flow here is going towards the future. Present value is going the other way around. So if we look at this example, you're still saving, let's say it's a house example, but in this case, you bought the house and now you end up with something called a mortgage. And I'll talk a little bit more about what mortgages are in the next lesson. So a mortgage is basically a loan for a house. So in this case, we're actually working the other way around. We already bought the beautiful house. Now we're thinking, okay, how are we going to pay this off? So your payments are really interested in, so you're really interested in the payments, looking at what the value of the payments are going backwards in time at the very beginning of time here. So it just depends where the direction of your payments are going, whether it's going in the future or the present, future or the past. So just be really careful with that when you're deciding on whether it's future value or present value. So last thing I want to go over is just how to use TMV Calculator to actually do the work for you. This is a really, really nice little trick, especially if you're looking at this and you're thinking, this is a little hard to do. So there luckily is an easier way to go through the calculations. So if you click on this first link that I give you, this is the most reliable one I've found so far. What you are going to do is you are simply going to type in the information that is given to you in the question. Now, before we even get to this, I just want to explain to you that this is just one way you could do it. I still definitely recommend that you learn how to actually do the calculations by hand or with a calculator on your own. But if you really get stuck or you just want to verify that the answer is correct, definitely use the TMV calculator. And I really do encourage you to use it for the homework because the homework, there is quite a lot of work. So to speed up the work a little bit, and since we're really more focused on the actually understanding, applying the concepts, definitely use the calculator. It'll be a lot easier. So I'm just going to talk about what each of these different letters and numbers mean. So the N represents the number of payments that we're going to be making. So again, we talked about this already. If it's annual, you don't have to do anything special. But if it's semi-annual, remember, you're going to have to take the number of years, multiply by 2. If it's monthly, take the number of years, multiply by 12, and so on. The big I, is the annual interest rate. And we always write it annually. And really important here, you write it as a percent. Okay, don't write it as a decimal. I know we're kind of used to writing it in decimals in the other as decimals in the other examples, but we're actually going to write it as a percent. Then present value, obviously PV is present value, PMT, regular payment, FV is future value. And then you get to these last two here, P/Y, C/Y. I don't want to go into too much detail what this means, but essentially just means how many payments you make per year. So if it is monthly, so to give you an example, if it's monthly, that means that the PY will be 12, okay? If it is weekly, then the PY, the number of payments per year, will be 52. And the CY underneath it is how many compounding periods there are. And all you need to know for now is you essentially want to make them the same. Don't worry about it for now too much about why it works that way, but we are only focused on examples where the number of compounding periods and the number of payments you make are the same per year, right? So they have to match up with each other. So if we make weekly payments, then we're going to be compounding weekly. If we make monthly payments, we're going to be compounding monthly, right? So that means that the number of payments per year and the number of compounding periods per year have to be equal to each other. So going back to this example here, if we want to calculate what the present value, future value, whatever it may be, using this calculator, let's just do an example here. So I'm going to go back to an easier one here that we can go through, and one that we already have the answer for. So going back to the last example that we just finished. So we're told here that we have a regular payment of 1,500. We're told the interest rate is 3%, right? So it's 3% right here, and we're told that we do this for 20 years, and it's monthly. Okay. So what I'm going to do is I'm going to look at that information and I'm going to fill it in here. So first thing, how many payments do we make? So we actually found that already. It is a total of 240 because it's 20 years times 12. So it's 240 payments. So I'm going to type in 240. What's the interest rate? So the interest rate, going back to this question, was 3%. So my interest rate is 3%. So that means I'm going to type in 3% in, 3% into the next line here. So I write 3. Present value, leave that empty for now. We are curious about the present value, but we're not gonna type anything in yet. Payments, how many payments did we make? Well, we go back here and we know that we made a total, sorry, how much were the payments? Sorry, how much were the payments? That's what I meant. The payments were 1,500. So I type in 1,500. Future value, don't worry about it. We don't have that yet. And then how many payments do we have per year? Since it's monthly, we know it's going to be 12, and we know that this has to be the same. It's also 12. So which one are we interested in this example? In this example, we were interested in how much I have to deposit today to get those future payments. So because we're actually focused on what's happening today, not the future, and we want to figure out how much I have to deposit today so that I can get those future payments, we are going back in time, which means that this is a present value question. I apologize, my writing is extremely messy. So we know that we're focused on present value because we are working backwards in our cash flow here. So all we're going to do is click on where it says solve for PV because we're interested in present value. And when you click on this, you end up getting $270,466.37. And if I am not mistaken, that was the exact same answer that we got, which is amazing because this does it for you. Of course, one thing you're going to notice, if you're using a cell phone, you won't be able to see all the numbers at once. It's actually going to cut it off. So you actually have to click on it so you can see the whole entire number. And unfortunately, you can only see segments of it. So the first time when you unclick it, you might only see, so let's give it, you might only see for example, right now I'm only seeing the last part of the number. And if I unclick it, I can only see the first half of the number. But hopefully you can kind of piece it together that it's 270,466. And then there's a decimal after, which is 37 cents. And another quick thing to remind you of, if you're going to notice that there's a negative sign in front when you calculate PV, and sometimes when you calculate the payment as well, ignore the negative. Don't even worry about what that means. We don't deal with negatives anyways, right? So just ignore the negative. When we talk about money, we never actually, when we actually are calculating a certain amount with money, we never talk about negative dollars anyways in this case. All right, so I think that's basically covers the majority of the lesson. I know there's a couple examples we didn't get to go through. I apologize for that, but I just wanted to show you how to use your calculator, how to go through the calculations, and of course, how to use technology to speed up the process a little bit for you. So I think that is basically everything for now. Please do your best with this lesson. I feel like lesson 2 is definitely the hardest one. So if you can get through this one, you're good with the other ones. They actually, believe it or not, get a lot easier. This is definitely the hardest part of this whole unit. The other lessons are just more terminology and understanding just how to do some more basic calculations here. Okay. Again, make sure you practice with using the calculator and also use the TMV calculator. Okay. There are multiple resources you can use for that as well. Feel free to look them up. But for now, you can use the one that I posted a link for. All right. Thanks very much. Bye.